जी वगैरे बरोबर आहे की नाही सर? नेट मोबाईल लागलं तर
हाँ मैडम कर रहे हैं हम
मैडम
मैम एक हो रहा है थोड़ा सा कर रहे हैं हम यूट्यूब पर लाइव का है। हाँ मैं करती हूँ लिंक शेयर आपको। हाँ
टीव्ही मध्ये मेसेज टाकून देणार 5 मिनिटं
गूगल मीट
नाही
अच्छा हाँ हाँ हाँ
करू का फायनल डिसिजन द्या तुम्ही करू YouTube ची करू
आज आपण हे बघून घेऊ सर बोला आज ह्याच्यावरनं करू आणि उद्या ह्याच्यावरनं बघून घेऊ सर आज संध्याकाळी
विचार मारून घेतो सर काही वांधा नाही 1.5 GB
बोला ना चालू आहे स्ट्रीम आले आता चेक
सर आले स्ट्रीम
कुठं
ठीक आहे इथे
लिंक नवीन आहे
तुमचं करा नाही तर मग
लिंक शेअर कर ना मग आम्हाला
काय प्रॉब्लेम नाही
ऐका ना लिंक शेअर करा कर ना तू आम्हाला.
करू मी
नाही नाही कोणती
याचं याचं झालं म्हणतोय लॅपटॉपवर जरा बरं पडेल
YouTube ती करताय तर मग Google Meet
गूगल मीट इथे ओपन करा पण का माहिती आहे आपल्याला पीपीटी
पहिले मी तिथं करतो पहिले
चालेल करा
मग तिथं पण करता येईल
हा चालेल
कशाला केलं
तुम्हाला
अथर्व बघू
Google Meet ची करू का शेअर
झाली सर इथनं गुगल मीट शेअर केली आणि
FDP मध्ये सर FDP मध्ये टाका ना कोणीतरी
आवाज यायला लागला आपला
कोणाच आहे
मॅम बोला तुम्ही
हाँ माझी लिंक
माईक चालू आहे.
अच्छा मैंने
मॅडम अरे ही लिंक आहे ना FDP वर टाका
हा मी टाकतो दिली
हाँ सर माझा लिंकची आहे ना
तीच
तीच लिंक कंटिन्यू करावं लागेल सर
तीच
गूगल
करा चॅट करा चॅट करा
कुठे जाईल लिंक तुम्हाला बरोबर आहे काम करा आणि ती येईल का लिंक
नाही ना डायरेक्ट चॅट
करू का शेअर ती
कोणती
Google Meet ची जॉईन करायसाठी YouTube कनेक्ट आहे ना आपलं
थांबा सर आता हीच लिंक कंटिन्यू करूया कारण ती त्याने कनेक्ट केली
सर एकदम ओके झाले या इथं तुम्ही
माझा मोबाईल इथं चार्जिंग आहे
तुम्हाला नाही आली
कसली
बोल
YouTubeची
हां मी बोलते सर आता मी बोलते
पण मॅडम
हॅलो एव्हरीवन
अजून कोण जॉईन नाही येत
आपल्याला बघा
हा येतोय मला
येतोय ना सर येतोय तुम्हाला
आणि FTP घ्यायची ठीक आहे
नाही
सर
यूट्यूबची शेअर कर ना आम्हाला
मग आता काय केलं
YouTubeची participant टाकणार
सरांना पाठवायचं आहे.
आणि ग्रुपवर
मला पाठवा
हां मी पाठवते मी पाठवते
हा, मी जे याच्यामध्ये पाठवतो
हे बघा हे
पाठवा ती मला.
आणि ती ग्रुपवर पाठवते मी आधी बनवून हो पाहिजे
गणेश सर मी तुम्हाला मी पण पाठवली बघा तुम्हाला
आलीच ना मॅडम चालेल ती पाठवा
मॅडम
मी FTP च्या
मी आपल्या एसएनची COP ला पाठवू का डायरेक्ट FDP वर पाठवा ते
FDP वर पाठवा
पाठवू का FTP वर? दोघे कसे पाठवतात मॅडम YouTubeची पाठवा लागेल ना त्याला कनेक्ट होईल याला कनेक्ट होईल त्यांना YouTube वर दाखवायचं आहे आपल्याला आणि बोलायचं मात्र याच्यावर हा मग मी फक्त YouTubeची लिंक पाठवणार आहे पाठवतोय हा पाठवू का
पाठवा
मी बंद केले मी बोलणार तर होणार आहे
स्टार्ट ओके मी पाठवली हा
यूट्यूबची ना
हां.
मला स्पीकर ऍड करू द्या ना आम्हाला
हा काय प्रॉब्लेम नाही आपण जॉईन होईल
तुम्हाला येतंय?
सर गुगल मीटची तुम्ही एसएनची COP वर करा
बरं बरं
आता तू PC वर कर ना आता इथे जॉईन कर ना
एकदम व्यवस्थित झाले आता आहे ना हे दार बंद करा आता.
हाल करू नका
मॅडम इथं कोणाला चिवून देऊ नका
YouTube आपल्या गुगल मीटची आपल्या स्टाफ याच्यावर पाठवत होतं SNGS UP मध्ये
एवढे नाही ना आपण 5-7 लोक राहतो गुगल मीट मध्ये नको जास्त
ठीक आहे मग तो त्यांना YouTubeची त्यांना पाठवतो आता
जे
YouTubeची पाठवतो
स्पीकर आणि जे बोलणारे तेच फक्त मुलीला पाठवा
YouTubeची पाठवतो आपल्या SNGS UP
भारतीला पाठवा खरं
तुम्ही बोलल्यानंतर
मॅडम फक्त 2च जण दिसतात आता
सर YouTube वरती चालू झालं YouTube वर यांना
तुम्ही गुगल मीट जॉईन करा ना तुम्ही
गुगल मीटला आपण 2-3च जण आहे
युट्यूबवर आहे मी आता
अच्छा
YouTubeला किती जण दिसत आहेत
हां तुम्ही नाही गेले
7वी वर्ष
गुगल मीट पण करा ना तुम्हाला बोलायचं आहे ना
मग कोण गुगल मीट कोण
मी तुम्हाला दिली ना
मी पाठवतो सर तुम्हाला गुगल मीट
हां
गुगल मीट कुठं आली आहे मला?
मी बोलणार आहे त्यांनी सगळ्यांनी Google Meet करा.
मॅडम गुगल मीट कुठं पाठवली तुम्ही?
पाठवलं ना सर.
गुगल मीटचे तुम्हाला पाठवतो
आता
सर.
तुम्ही फक्त स्क्रीन शेअर करून तुमची PPT किंवा काय
PPT इथून करावं लागेल मला.
नाही, तुमचं नॉर्मल असतं.
मॅडम गुगल मीट तुम्ही पाठवलेली नाही आहे.
पाठवतो सर तुम्हाला आणि बघा.
प्लीज जॉईन आले फक्त.
मी बघा
आले
पाठवतो
गुगल
तुम्हाला.
मीट.
YouTube चालू आहे ना? YouTube चालू आहे ना?
हो,
रेकॉर्डिंग होते ना तिथं?
रेकॉर्डिंग नाही
रेकॉर्डिंग
चालू
नंतर
कर.
कर.
लाईव्ह स्ट्रीम चालू आहे. रेकॉर्डिंग पण चालू कर.
रेकॉर्डिंग आपल्याला स्टार्ट केल्यानंतर करायला पाहिजे, कळलं का? आणि बाकीचा आवाज येतो.
गुगल मीटचे पाठवतो तुम्हाला.
त्याच सुरू करणार आहे ना आपलं. आणि त्याच सुरू करणार आहे सर. आले सर आताशी तुम्ही जॉईन झाले. करते मी बंद करणार इकडे केल्यावर. आता ही बंद करून टाकून
याला गुगल आपल्याला जॉईन होतात ना मुलं,
हा,
म्हणजे स्टाफ जॉईन होतात
युट्यूबला
युट्यूबला
सीझन
झालेत 11 जण आले.
हां आपलं करता आवाज येतो.
तुम्ही एकच ठिकाणी लॉग इन राहू नका.
हां मी करू मला काय
किंवा
करायचं
कुठलं तरी माईक बंद राहू द्या. मॅडम नाही करते.
2 जणांचं माईक चालू आहे.
माईक बंद कर.
मी करू का? मॅडम तुमच्या माईक बंद करा.
डायरेक्ट आउट एकच
कोणाचं आहे
सगळं.
आपलं? कोणाचं mic चालू आहे?
मी एमपीपी तुम्हाला दाखवणार शेअर करणार आहे PPT.
सर तुमचा माईक चालू नाही का? तुम्ही माईक बंद करा. Yes, आता बंद करा.
ते माझ्याकडे बघत माझं
ओके. सरस
करतो
मध्ये.
का नाही तर तू कर. शेअर. दिसतंय.
सरांनी त्याला
सर मी सांगते का स्क्रीन बंद ती दिसते
कशावर?
गुगल मीटवर.
स्ट्रीमवर पण दिसते.
मी हे याच्यासाठी लावायसाठीच केलं ना.
हां ठीक आहे चालेल.
नाही लावत ना.
रेडी सर.
रेडी, ऑल द बेस्ट.
विंडो सरांना काय प्रॉब्लेम आला आहे सरांना.
मोबाईल राहून द्या, सेकंड राहून द्या.
कॅमेरा इज ऑफ झालेच सर जॉईन. मी सरांना जॉईन केलं. जॉईन केलं त्यांना. मी न्यू भेटे आहे.
आवाज खूप असा असतो. मॅडम तसंच करावं लागेल. कोणाचं तरी स्पीकर ऑन करावं लागेल आणि त्याच्यावर आवाज पाठवावा लागेल. दोन
हां ते तुम्ही तिकडे जा.
हा ते चालू झाल्यावर मी करतो.
बरं मी चालू करायचं का आता आपण.
मला सरस्वती वंदनाचं सांगा.
सर विंडो छान आली आहे.
मॅडम मग तुम्हालाच
ठेवू चालू.
किती जण जॉईन झाले ते बघून घ्या ना पैसे. किती आले?
सारखं सारखं नको विंडो हलवतो.
युट्यूबला किती आले?
18.
करूया आता आपण. येत आले
तुम्ही कुठे मेसेज टाकू का मी ऑल ऑफ यू जॉईन फास्ट.
मी टाकलाय तसं ऐकलं. फक्त मला सरस नाही मला दुसरं
काहीतरी बोलतो.
हा सर हा येस सर वेटिंग फॉर पार्टिसिपेंट्स.
फक्त कनेक्ट करा.
गुड मॉर्निंग सर. युपी आवाज येतोय ना एकदम परफेक्ट. हां एक सर साखर आहे का त्या ए नाही इथे पोलीस जरा जा तिकडे. सर तुम्ही बोलावलं
पेपर नंतर तुमचा मोबाईल घेऊन सरस्वती वंदना झाला की निघाले.
ते आपण सगळे गुगल पे जॉईन करा आपण.
नाही मी युट्यूबची केली आहे.
युट्यूबची पण शेअर केली आम्हाला
मी जॉईन युट्यूबला.
सरस्वती वंदना शेअर करायची ना मला ती नंतर करून ना.
विजयी कळे पण आले आपल्याकडे.
Good morning to everyone and welcomes to you all my respected. As we know that the every good work begins with God blessing. So first of all, we are starting with Saraswati Vandana. Thank you all. Now we are starts with the today's session. Welcome to FDP on exploring spectroscopic and chromatographic techniques for Pharmaceuticals on behalf of Shivaji Rao S. Zondare College of Pharmacy, Asangam. Now we are moving towards the very interested, informative, helpful session of FDP. We hope so. It will be a great day of you all faculties and my respected. Thank you all. Now I am requesting to the Dr. Nitin Mohire sir of our college, Shivaji Rao S. Zondare College of Pharmacy, Asangam, to proceed with welcome address. Thank you so much.
Delegates and organizing committee the faculty development program on pharmaceutical analysis. I hope Professor will take this charge to introduce all the keynote speakers with renowned names and experience in the field of pharmaceutical analysis. Sanap Madam, please introduce the keynote speakers. Thank you.
Thank you so much, sir. Now proceed further. I am requesting to Professor Manjusha Sanap ma'am to give the little idea about overview on FDP.
Good morning, everyone. Myself, Manjusha Sanap, Assistant Professor from Shivaji Rao S. Zondare College of Pharmacy. First of all, I welcome you on 5-day online faculty development program on exploring the spectroscopic and chromatographic techniques for pharmaceuticals. The overview of our FDP. So we arrange this FDP with an objective of exploring different modern method of analysis in pharmaceutical testing to study the qualitative and quantitative analysis of drugs using various analytical instruments, to learn the structural elucidation by spectroscopic methods, as well as to learn about the modern methods of separation in herbal drug analysis. This FDP will emphasize on various modern spectroscopic techniques like UV visible, IR, NMR, and mass spectroscopy and their applications, as well as the different modern separation techniques like HPLC and HPLC and their use in analysis of herbal drugs. So this 5-day FDP, this is our day one. So this day one is start, means this session, it containing 2 sessions. First session is start at 10:30 and second session is start at 11:30, and at the end of this FDP, or at the end of these 2 sessions, we are giving you one feedback link. So you have to you have to give your feedback each and every day, so it consider as your attendance. So to arranging this FDP, our principal sir, all the organizing committee, they are taking to a lot of efforts. So thank you very much, all the participants, to join this FDP. Thank you.
A very thank you so much, ma'am. Ma'am also again will give you an introduction keynote of today's session of honorable resource person.
We are very fortunate to have an eminent speaker. We have an eminent speaker for today's session, Dr. Amol Khade sir for first session, and Dr. Vandana Jain ma'am for the second session. So first I introduce Dr. Amol Khade sir to everyone. Dr. Amol Khade sir, working as a principal in Indira Institute of Pharmacy, Sadauli, Ratnagiri. Sir completed his PhD from Manipal Academy of Higher Education in 2020. Sir having around 15 years of experience in academics. Sir worked as a IQSC coordinator in his institute. Sir also work as a member of Flying Vigilance Squad for university examination by the University of Mumbai. Sir work as a practice center coordinator for NTA. Sir approved as a PG guide from University of Mumbai. They also work as a evaluator for Smart India Hackathon for the year 2021-2022. Sir also a editorial board member of Pharmaceutical and Chemical Journal. They also work as a joint secretary and chairman for International Conference on Healthcare and Technical Research that held at Manipal in December 2015. Sir also a reviewer of critical review in Analytical Chemistry and Indo-Global Journal of Pharmaceutical Science. Sir received a certificate of appreciation from APTI Mumbai for for his contribution in Nanganga as a diamond contributor. Sir received a Best Teacher Award in 2017-18. Sir also received a Best Poster Award in international conference which are held at Goa College of Pharmacy, Goa. So, so many more to say about this, sir. Sir also received a minor research grant by University of Mumbai. They also serve as a resource person in various conferences and seminar. Sir published around 28 articles in various national as well as international journals. Sir published a book on pharmaceutical chemistry in innovative publication. So, sir presented a poster in almost 15 conferences. So, lot of to say about this, sir. Means this 10 minutes not enough to say about this, sir. So, I welcome Dr. Amol Khade, sir, on behalf of Shivajirao N. Zondale College of Pharmacy. Thank you, sir. Now you start your session, sir. I request you, Amol Khade, sir, to start your session.
Thank you, ma'am. I will share my screen. Just ensure it is visible to all of you. Whether my screen is visible? Hello?
Yes, sir.
Whether you could able to see the screen which I have shared?
Yes, sir. Screen is visible.
Okay, fine. So shall I start?
Yes, sir.
Okay. So first of all, thank you, Shivajirao Zondale College of Pharmacy, Asangao. Especially thanks to Principal Professor Dr. Nitin sir and Manjusha madam for inviting me to deliver the session on separation by column chromatography. So as we all know that the audience today for this online FDP on exploring the various chromatographic and spectroscopic analytical techniques for pharmaceuticals. Nowadays, these are very crucial. And when we go to industry or even in research laboratories, we see lots of focus and emphasis is given on the chromatography and spectroscopic technique rather than the conventional techniques which we study in our B.Pharm or M.Pharm. Now, coming to the column chromatography, we have studied this column chromatography since our B.Pharm, and we know the chromatography was discovered by the scientist who was actually the botanist, Michael Sweat, and he came up with this technique in long year around in 1906. So what he did, we know that he took a big glass column and he filled that with the stationary phase, what we call it as a calcium carbonate, and then he loaded the plant extract which he extracted, and then it was eluted with the solvent which we call it as a petroleum ether. And then he observed that over the period of time, when the elution was continued, we could see the development of colored bands, and that is how the separation of mixture, which was a plant pigments, got extracted into the fractions or the bands, and then he has separated that, eluted that, and identified which were those fragments. So the green color was chlorophyll and all those things, flavanoids and all. So that is how we know the story of how the chromatography came into picture. And then nowadays we see the chromatography has developed a lot, and we see the number of chromatographic techniques which are in use, be it in a research, be it in a industry, or be it in a regular monograph methods which are used in day-to-day industry work. So we know that the separation is based on usually the adsorption phenomena, and sometimes it is a partition phenomena. So based on what kind of stationary phase we are using, we refer it as a normal phase chromatography or the reverse phase chromatography. So we see the components which we are adding, they may have the weaker interaction. So weaker interaction will be retained by the column. The weaker interaction components will not be retained by the column. They will be carried away from the column with the help of mobile phase, and the analytes or the components which has the stronger interaction, they usually interacting more with the stationary phase, and they will be eluting slower. So we can see here the red component of the analyte, which is having a weaker interaction with the stationary phase, is moving faster, and the one which is having the stronger interaction will be eluting later. So you can see in the chromatogram, the first which is coming out, that is the analyte having a weaker interaction, and the one which is eluting slower, that is having a stronger interaction. And that is how we can separate the components, be it in a TLC, be it in a paper, or on a particular column. So this is how exactly the column looks like. So this is a simple glass column, and you can see the stationary phase, which is most of the time the cylinder which is packed in this column in a, and then we load our sample and then we use the mobile phase. So coming to the practical aspect, this was the kind of introduction. All of us has studied the basics of column chromatography and all, but how we can practically use this column chromatography. Suppose if you have any crude compound which you have synthesized, or if you have any plant extract which you wish to separate or which you wish to screen for a particular biological activity, or the synthesized compound if you wish to characterize. So it is always better that if you have a pure compound in hand, then obviously you will get a very neat and clean spectra which you can rely and which you can easily predict what could be the compound, or you can confirm whatever you supposed to synthesize has been synthesized or not, or whatever you wish to isolate from the plant or any herbal thing has been extracted or not. So in that aspect, the chromatography, especially the column chromatography, is a simple technique which you can utilize, and you can separate your compounds, you can remove the impurities, and you can get your work done. So columns are generally used in, we see pharmaceuticals and even in organic and inorganic labs to remove the unreacted starting material. So most of the times we add some catalyst or we add some many reactants and all. So at the end of the reaction or the completion of the synthesis, it is much obvious that all the starting material is not getting utilized, or there are some catalysts which are they have done their work and then it needs to be removed. And with our simple recrystallization or filtration or even the workup of reaction, we know that most of the things are not getting carried into the product, but there are some traces of impurities or unreacted material, which also comes with the crude product. So we need to separate them, and that is where we can use the column chromatography. So done right, it can be simply and quickly. We can isolate the desired components from the mixture. But we know that even when we see the TLC or even in the paper chromatography, it looks very simple. But when we go actually doing that particular column chromatography, we find though it is difficult, but there are so many practical things which are involved, and sometimes we end up with the mixing of those components, and they're not getting eluted properly or not getting purified properly. So though it looks very quick and efficient and simple, but doing column is sometimes that you should practice actually, and it will usually take years to master to separate or purify your desired components. So we'll discuss some of the tricks and the practical aspects of doing column chromatography. So whenever you have any crude compound which you have synthesized, or you have some compound which you have recrystallized, still there are some impurities, or if you have any extract which you wish to purify or isolate, then first thing what you should do, that you should select the solvent system for elution, right? So usually people ask me how we can select the solvent system for column chromatography. So what we should do, it is always preferred to have a TLC. So you can take a pre-coated TLC plate, probably the silica or alumina plate. So whatever the stationary phase which you are going to pack in the column, the same TLC stationary phase you can use, and then you can have a prototype of your sample to be spotted on the TLC plate, and then you can play with different solvent systems and develop the TLC plate which will have a proper or appropriate RF value. So this is perhaps it is based on the trial and error basis, and you should use your organic chemistry knowledge and see what solvents you can use to the best so that it can separate at proper RF value. So in chemistry lab, we know there are a huge range of solvents, and probably what you can do, you can see the polarity index chart. So as we know, there are a number of solvents which we can use, but there are certain things which we always keep in mind when we select the solvent system, right? So we know the polarity index near to 0 it is highly non-polar, and towards the 10 it is highly polar. So these are the range of solvents which we can probably use in solvents as a solvent system in column or TLC. And then we can see the miscibility also, because whatever solvents we are selecting as a mobile phase, they should be miscible with each other. So this is the miscibility chart and the polarity index chart, which usually we refer for TLC. The same chart you can refer, develop the TLC plate, and then you can take that as a hint or as a yardstick, which you can use it for doing a column chromatography. So while choosing the solvent system for elution, certain things we should keep in mind. So elution is normally carried out with mixture of two solvents as a mobile phase. So one being the polar and other one usually non-polar or the moderately polar. So usually in column chromatography or even in TLC, we prefer to have usually non-polar solvents, and to some extent we can use moderately polar or polar solvents. The reason behind that, whenever we perform the elution, so after the elution what we need to do, we need to recover our sample, right? We have to evaporate those solvents which we have used for elution. So it is always advisable that we should use volatile or non-polar solvents, which can be easily removed at reduced pressure using a vacuum rotavapor, and then you can get your desired product in a pure form. So sometimes we see single solvent can also be used. Again, it depends on how many components or what kind of impurities are present in your mixture. And then you can perform isocratic or gradient elution based on the nature of sample or what kind of RF value you have and how many components are there in your particular mixture. So when I interact with the students or even some of the faculty, usually people ask whether we can do the gradient dilution with the column chromatography. And the answer is yes, you can do the gradient dilution even with the column chromatography, like what we do in HPLC or even in GC. We know the it is a temperature programmed and all. So yes, isocratic elution, definitely people are doing isocratic elution, but even you can perform a gradient elution using different ratio of mobile phase. You can keep on increasing gradually the polarity, and then definitely you can perform much better separation at a very shorter time by carefully doing a gradient dilution. Especially this is done for the compounds which have very close RF value, and though you are using or playing with different solvent systems, you if you could not able to separate them with the proper RF value, then yes, definitely you can perform even the gradient dilution using the column chromatography. So many people have their favorite solvent system, and they will automatically start with their solvent system, and then based on the separation what we are observing on TLC, then we can increase or decrease, or you may add one more solvent into that, and then you can get the RF value. So usually when I prefer to choose a solvent system, I usually start with hexane and ethyl acetate, or petroleum and ethyl acetate. So this is my preferred solvent system whenever I do not have any idea about what kind of sample or kind of solvent system we need to choose. So usually you can start with 8:2. So you can take 8 fractions of hexane or petroleum ether and 2 fractions of ethyl acetate, and then you can spot your sample on the TLC, and then you can develop the plate, and then see how the samples or the fractions are getting eluted, what is the RF value, and based on that you can increase or decrease the polarity by changing the ratio of hexane ethyl acetate. Another solvent system which I prefer, and even most of the people prefer, is chloroform and methanol. So we know that the chloroform has a polarity index near to 2 or 3, and methanol is a bit polar. So we can have very little amount of methanol and good amount of chloroform. Usually you can have 9:1 or 9.5 and 0.5 ml of methanol, and then you can develop the TLC plate and see how your sample is getting migrated on the TLC plate, and then again you can keep on changing the ratio. If it doesn't work with the hexane, ethyl acetate, or chloroform and methanol, then you can have a number of other solvents which you can probably try, and then you can develop the solvent system which is showing a proper RF value. Okay, so this is the chart showing different kinds of solvent system. So even ether or dichloromethane is also solvent system which you can use. And choosing the solvent system for elution such that it should elute your desired compound without impurities, because our main objective is to get a pure compound, or the isolated things which we are interested. So it should give the desired component at a better RF value, and as far as possible the separation should take place with little amount of solvent. So in column chromatography, one of the limitation or drawback we can say, you need to use a good amount of solvent, because you need to keep on pouring the solvent, and it is getting eluted, and most of the times we cannot recover and reuse the solvents, right? And ultimately it is going into the environment. So we should develop the TLC plate in such a way that it should have a better RF value, and the component which you wish to separate, it should be probably on the higher RF value side, so that the impurities can be settled down at the bottom, and the one which are at the top you can easily elute out. Then next is, it allows recovering and reuse of eluted solvents. So this is preferred only when you have the impurities which you can tolerate, or you can use those solvents for cleaning and all those things. So in that case, you can recover the solvents and you can reuse the solvents for some other work. But it is not advisable when you are having some solvents which are not toxic and these kinds of things, right? So it is always quicker to run an extra TLC than to set up a column that doesn't work. Otherwise, you will spend a lot of time and even the resources, and then ultimately your analyte is not getting eluted. So you will be frustrated, and then you have to repeat it, right? So there are some hints, and I can show you how or the what kind of resolution we need on TLC plate. So the end result should be a solvent system that moves the target compound about at least 1/3 of the total solvent path, right? So probably for doing a column chromatography, it is always preferred to have the RF value between 0.25 and 0.35. So you can see here what we can do. We have taken a TLC plate. So this is a baseline, and this is unreacted starting material, which we have spotted as a reference material. And this is the product which we are desiring to get after the synthesis. And this is our reaction mixture. So we are probably assuming that the reaction is complete, and then we are developing the TLC plate and solvent system for that, right? So you can see in the reaction mixture, the product spot is observed here, and it is matching with that reference. And then the unreacted or the reactants are at this particular point, right? So it is 0.5 and this is 0.3. So this is, we can say it is a acceptable and ideal for separation. Now when we look at the TLC separation, we know that this is against the gravitational force, but when we do the column, this is towards the gravitational force, right? So probably at 0.35 or 0.4 or even near to 0.5, it is considered as a ideal kind of RF value on the TLC plate. And you can see the product spot is on the higher RF value side, or it is on the top. So when you load the column, the one which is eluting first, which has a weaker interaction with the stationary phase, will be eluting faster, and then you can collect this particular spot or the fraction through the column. Then you can evaporate the solvent using a vacuum rotavapor, and then the impurity is let inside in the stationary phase, and then you can discard that stationary phase. So what you wish to separate, that product, it is coming out in the beginning, that is always better, right? So sometimes it is possible, sometimes the product may be at the second or third line, and then the impurities are on the top. So you should preferably select the solvent system in such a way that the product spot, as far as possible, they are falling in between 0.5 to 0.35 RF value, and they usually on the top, right? So this is one thing what we need to consider. Then we should not be tempted to use the solvent system with higher RF value. So especially if this is only the solvent system which you have tested, so faster elution can result in an impurities being masked by the another spot. So you can see on the left side TLC plate, so this is moving faster. So this usually happens when you use chloroform methanol, and if the methanol concentration is very high, so usually we see this kind of separation. And when you see the RF value is very high, near to 0.7 or 0.8. And when you look at this TLC plate, you can say that the spot which I am able to see, it is exactly matching with the product spot. So you may be ensuring that this is the purified product, right? But when you do the column, right, what happens? It might have some impurities which are also traveling with that. So this kind of separation is not ideal. So you can see here, by using another solvent system or by changing the ratio of the solvent system, we can see there is one more spot which may be of impurity or some kind of unreacted material, that is actually very close to that. So if you are using this kind of solvent system, the product was moving along with the impurities, and it was at the same RF value. So if you are doing a column, it is high probability that you will end up with impure product. But if you are getting such kind of development on the TLC plate, then you are ensuring that the impurities are actually separated, right? Though it is quite close. So in such case, we can use the gradient dilution, what I explained in the earlier slide, right? Then sometimes the opposite is also true. The desired compound is the one which is later eluting spot. So here it is possible for the spot to be too slow moving spot. So you can see here. So these are the impurities. There is the desired compound, and this is the reactant mixture, or your reaction mixture, right? So you can see the impurities are moving faster, whereas the desired product is moving slower, right? So you can have the problem if your desired product is not moving faster, you have developed that type of solvent system. So there is a high probability that if your product is having a very stronger interaction with the stationary phase, and if it is remaining for the long time in the column, there is a probability that your compound may react with that, or it may undergo the degradation, right? So it is always preferred to complete your elution within a day. Sometimes it may go 2 or 3 days, but as far as possible, you should elute your compound as early as possible, so that if you are allowing your sample to remain inside the column or with the stationary phase, there is a high probability that your compound may undergo degradation, and then it is very difficult to get that out. If it is degraded, then it is of no use, right? So that is to be considered. Then ideally the spots should be round and distinct from each other, like what we can see here in line number 1. And sometimes we can get the oval shaped spots, right? So this is also okay. You should not be worried much. Even if you are getting these types of spots, you can do it comfortably. Don't increase the polarity at very beginning. You can slowly go with that. Definitely you can separate both of them, or whatever you wish to. So spots with long tail on TLC plate can translate to wider bands, and possibly they will be overlapping on the actual column. So you can see if you are getting such type of separation, there is a high probability that you may get initial fractions in the test tube which you are collecting. So initial 2-3 test tubes may be of your desired product, which is indicated here in the pink. But in between, like in between the test tubes which you are collecting, so that may be having a mixture of both of them, and then at the end again you will be getting the blue one, right? So such type of, again, overlapping is not advisable. It will be considered as a tailing, and you need to work it on the solvent system, or you can add one more solvent system and check how better you can have separation on the TLC plate, so that you can have better separation in the column chromatography. And other factors which we should keep in mind while selecting the solvents, that is the price of the solvents, right? So usually petroleum ether or ethyl acetate and all those things, they're quite cheaper. And usually what we do, we use the laboratory grade, or at the most the analytical grade solvents for doing this. Non-halogenated solvents should be used, because if those are present, again, if you are interested in taking the spectral data, then definitely it will be trapped in those. So it is worth nothing here that some cheap hexane or petroleum ether, especially those comes in plastic container. We know ethyl acetate or the chloroform and all, they comes in plastic container, and usually they contain the impurities as saturated hydrocarbons. And when we look at the NMR spectra, they will be trapped in between 1 to 1.5 ppm. So if you are using these kinds of plastic containers for these solvents, it is always advisable you should distill those, or you can, if you can afford, you can go for better grade solvents, right? Then choose the solvents which should have the lower boiling points, right? So chloroform, petroleum ether, ethyl acetate, or you can have the acetonitrile and all those things. So usually they have the low boiling point, and these kinds of solvents we should prefer so that we can easily evaporate them under reduced pressure using vacuum rotor vapor, and we can get our compound which we wish to purify. The next is, and that is again important, choosing the correct size of the column. So usually people have this question, how we can select the size of the column, right? So theoretically it is possible to use a very thin column with long length, or you can do vice versa, shorter length of column with better diameter, right? So choice of column size is less important than the amount of silica which is used. So you can see here, this is a lengthier column, right, having shorter diameter, so occupying this much amount of silica. And on the other side, you can see the column with larger diameter and having the same amount of silica, right? So it is not the size of the column, it is actually the amount of silica which actually matters for doing the separation, right? So most people will choose a column size that allows to fill the column approximately 1/3 to half of the silica, because the remaining will be your mobile phase, and then you can carry out the separation. So this is the image which actually help you to select how or at what level the silica should be filled in a particular column. So you probably might have seen such type of columns. So on the top of this column, glass column, it will have the solvent reservoir, because then again and again you should not require to fill the mobile phase in the column. So this is a solvent reservoir which can hold around 500 ml to 700 ml solvent capacity, and then it will be keep on eluting, right? So this is the table which indicates for selecting the amount of silica, right? So for diameter of 10 mm, if you are loading the sample, right? So for 100 mg, if RF value is 0.2, so this is the ideal weight which you can prefer to. So this is a rough guide, right? So for 20 mm, then 30 mm, 40 mm, and 50 mm. So usually 50 mm, which is roughly around 2-inch diameter of the column, right? So 2.5 gram can be used if RF value is greater than 0.2, and if the RF value is near to 0.1, that means it is highly polar, then you can load 1 gram, right? So this is the optimum size, usually 1/3 or at the most half of the total height of this particular column, which is actually usually practiced while you are packing the column with the stationary base, right? Then how much silica is needed to pack the column? So again, it depends on how much sample we need to separate. So the ratio of silica to sample does not have to be exact, but should be taken sensibly to prevent waste of both your time as well as resources. Because we see many times the people are packing the column, very lengthier column, and they have, though they have developed the TLC in a very better way, they have selected the solvent system, the RF values are also good, but they pack very lengthier column and they keep on wasting their time and resources to take out the desired compound out of the column, right? So it will be a very wastage of time and even the resources. So it is always advisable to measure the silica by weight rather than volume, because we know that the silica what we are using, it is a very fine silica, usually of 100 to 200 mesh size, and like rather than going on the volume, always it is advised that you should weigh the silica and then you can accordingly pack that, right? So depending on that, again, what kind of silica you are using or what kind of alumina you are using, that is again matter of concern. The amount of silica required is how easy or difficult the separation is going to be, right? So I have one table here again, which you can use it for uh, identifying or deciding the ratio of that, right? So if you have developed the solvent system on the TLC plate in such way, so you can see the RF value is what we explained, 0.35 to zero point 0.5. So this is easy separation, right? So this is easy separation. So you can see 20 parts of silica and 1 part of your sample, right? So this is the ratio of silica which you can choose. Then you can see the medium separation. So this is 50 parts of silica and 1 part of sample. Then if you have difficult separation, difficult in the sense the RF value is quite close, right? So in that case, you can use 100 parts of silica and 1 part of sample. Okay, so this you can use it as a guideline. Then I have shown here some of the images of columns which you or we usually prefer to use in column chromatography. So this is the column which is widely used for doing separation, right? So as I mentioned, 1/3 of the total height or at the most half of the total height is used. So it has a stopcock, right? And it has the particular size. So usually now people what they do, they put one neck here, and for faster elution we apply the pressure. So we can use the aerator, and then when you put the solvent you can connect the rubber tubing of aerator, and then you can open the knob. So the movement of mobile phase passing through the stationary phase is faster, and you can complete your work in a better time, right? So this is what we can use as a gas inlet, right? And then you can connect your rubber tubing from the aerator. This is your solvent reservoir which can hold the mobile phase. Again, some column comes with the connector, and some columns you can see this one. So this is without the connector. So it is replaceable, and this is not replaceable, right? And you can see there is a connector here. There is a glass tubing, and then you have a rubber tubing which is coming from the aerator, which is actually creating the pressure on the solvent system, so that the solvent is moving through this particular column in a faster way, right? And even we can see people are using, especially in the research laboratories, or if you are synthesizing something for the first time, or if you are setting some reaction batches just to know whether your reaction is happening or not, right? So that time the amount of product which is getting formed in a reaction mixture, that is probably not more than 10 mg or even less than that. So in that case we can use a pencil column, right? So this is a pencil column. It is almost similar to the pipette what we use in a laboratory, right? And it does not have the stopcock, right? So you can see it is exactly similar to the pencil size and similar to the pipette, only it does not have the calibrations, right? And you can pour the silica, and then you can load the sample. So this is in pencil column, as the diameter of the column is getting narrower, we should prefer to go with the dry packing method for packing the column, right? So we'll discuss that also in the coming slide, how we can pack the column by different methods. Then column packing, choice of silica or alumina for the stationary phase. So we often see that the silica is the preferred one. Even when we perform the TLC, we know that silica is mostly preferred, and for certain type of compounds we can also use the neutral alumina or basic alumina and so on, right? So silica, as we know, it is slightly acidic, so it is used mostly for all the compounds, but because it is having acidic nature, it retains the basic analyte. So that should be kept in mind. And the size of the silica, that we refer it as a mesh size. So usually the silica comes at different sizes. So it is ranging from 230 to 400 mesh size, right? So mesh size is what it is the sieve what we are using. So how many holes are there in per particular unit, that is referred as a mesh size. So higher the mesh size, that means the finer or shorter the size of the silica, right? So 70 to 230. So this is the mesh size which is usually preferred for the gravity column. And if you have synthetic kind of compounds which you wish to separate, organic or inorganic, preferably people use 100 to 200 mesh size. If you are having the natural compounds, right? So usually people prefer 70 mesh size, 70 to 100. Again, it depends on what kind of mixture you have, right? And we consider this flash column, right? So as we know, TLC has atomized system as a HPTLC. So same like in column, the column is atomized as a flash column, right? So where it has the detectors and all. So if you are using a flash column, usually the higher mesh size is used towards the 400, because again in that case you have the pumps which can forcefully deliver the mobile phase to pass through the packed column. Then you can use the alumina. Usually the basic alumina is used, so it retains the acidic analytes, obviously. And then this alumina, instead of mesh size, it is categorized into 1, 2, and 3 types. Okay. So this 1, 2, 3 is based on the water content it has. So the 1 is having the least water content, whereas the 3 type is having the maximum water content, right? So alumina of activity 2 or 3 is most commonly used, and when you consider the mesh size, it is approximately 150 when compared to the silica. So this is most commonly employed for separation with the help of alumina as a stationary phase. Then again, if you see the manufacturers which manufacture these columns, the columns comes also with the fritted columns, right? So you can see this particular column in the diagram. At the base, there is a glass frit, right? So what is the purpose of having this glass frit? So this is a very porous type of glass frit, and this will actually help to retain the stationary phase inside the column. So it will not allow the silica or alumina to come out of the column, because we need to retain the stationary phase, right? So for that, some columns are equipped with the glass frit, right? So you need to clean that after use, right? So that is there with the fritted column. So find a clean, empty column of suitable size, then clamp the column securely and close a tab or a stopcock, and then add a layer of sand, approximately 0.5 centimeter to this. So though it has a glass frit, still we add little amount of sand so that it will not have problem. The finer particles should not come out of this glass frit, right? Then usually we prefer to use these normal columns which does not comes with the glass frit. So probably what you can do, you can prepare a cotton plug, and then you can appropriately place this cotton plug at the end of this, right? So while putting this cotton plug, you should be very careful. So you can take a lengthier glass rod, probably with the flat end, and then you can prepare a cotton wick, right, pointing towards the down. So if it is having too smaller size, there is a high possibility that the cotton plug can easily come out of the column, and then it will not retain the stationary phase. So this is the ideal size, right, which you can see here. So if it is too large, then there is a problem that the mobile phase will be dripping at very slow speed, right? So ultimately it will create a lot of time to elute your desired compound. If it is too small, it will not retain the stationary phase. So you should really work it on and select the appropriate size of the cotton so that it can hold the stationary phase. At the same time, the dripping of mobile phase through the column will be at optimal speed, right? And then if required, you can add some solvent, add some sand, right? Again, this is not the sand what we use regularly. This is a special grade sand which is available commercially, and we should prefer to use that because it does not have impurities and the size of that sand is very uniform. So you can add this particular sand, and then you can pack your column. So column packing can be done by different ways. There are basically two methods. One is a dry packing and other one is a wet packing, right? So you can see here option one, that is dry packing. Again, there are two methods in dry packing. So you can see there is a cotton plug and you have placed the sand. Then you can add the solvent or your mobile phase and then you can elute the column, right? So whatever the air bubbles and all those things present in the cotton or in the sand, that will be taken away. Then you can take the dry funnel and then you can put the funnel and then put your stationary phase, that is the silica, right? And then allow it to settle down. So then you can open the tap and see to that all the solvent has been completely drained out from the column. And once it is done, then you can load your sample. So this is one of the dry packing method. You can use the rubber vacuum tubing or cork type tab so that it can take out the solvent which you are used for packing. So this is dry packing. Another method is what the people usually do, especially with the pencil column. You can take a dry glass column, then put the cotton and a little amount of sand, and then simply pour the silica. Okay, and then you can take a rubber bulb and simply tap on the outer wall of the glass column so that the silica will settle down, and then you can add the solvent system. Then it will be solvent will be equilibrated with the silica, and then you can load your sample. Okay, so this is the dry packing method one. So here it minimizes the washing up, and the columns are difficult to get a well packed column in this case because there is a probability that it is loosely packed. Then another method in dry packing, the initial methods are same: put the cotton plug and then sand, and then add the silica, then allow it to settle down. So when you are adding the silica from the end of the column, you can open the tap and apply the vacuum. Okay, so with the help of vacuum, the silica will settle down. Then pour the solvent. Again, it will be equilibrated, and then again apply the vacuum and make sure that it is settling down the stationary phase what you have, and then it will be packed properly. Okay, so this is a tight packed column which is usually preferred in separation, because if you are packing loosely, then again it will create a problem in the elution. You will not get a properly eluted spot which you have separated on the PLC plate. So here the drawback is it will require a lot of solvent. And the next method which usually people prefer, that is the slurry method, or we call it as a wet packing method. So in this case, what we can do, we can make a slurry of silica with the solvent system which we have selected. Now it is very obvious that if you are doing an isocratic elution, the solvent system what you have used, let us say the chloroform and methanol in 9:1. So you can prepare a solvent system in that ratio in the beaker, and in the same solvent system you can prepare a slurry, right? Then you can mix it well with the glass rod, and then doing this initial setup, right? Then you can pour the some solvent, and then you can add the silica slurry, right? And then you can do the tapping. Again, you can take a rubber bulb and tap that rubber bulb from outside the column so that the silica should get settled down, and then open the tap. So this is how we can pack the column with the help of wet packing. Then you can have the lengthier glass rod having the flat end at the bottom. Then you can put the glass rod in this after pouring the silica slurry, and then hold this column from the bottom and gently and slowly tap down the slurry which is settling down here. So that is how you can pack the column. This is most preferred method for doing the separation, especially in the synthetic laboratories. Then once you do that, then what is next? You can equilibrate the column with the solvent system for 2-3 runs you can give, and then you can load your sample. Now, while loading the sample, what should be kept in mind? Again, loading of sample can be done by various ways, but usually it is always advisable that you should adsorb the sample on the silica or the stationary phase what you have used, right? So how you can do that? Take your sample, dissolve in a particular solvent, maybe the same solvent what you are using for this solvent system, and then add some silica into that. Take that mixture in the round bottom flask and then evaporate the solvent in the vacuum rotavapor. Then you will have a very free flowing silica on which your sample is adsorbed, and then you can put the funnel and then you can add your adsorbed sample on the top of this particular silica, right? Then again elute for little amount of time, and then again what you can do, you can take a silica slurry, only silica slurry, and then add the 1 or 2 centimeter layer of your stationary phase. So this is done why? Because when you pour the solvent, there is a possibility that the sample which you loaded on this top end, that may get disturbed. So if you are pouring the solvent, let us say from this end, there is a high possibility that because of the pressure, the sample which loaded it is going inside from this point, and this is upside or as it is on this side. So that is again creating a problem, right? How it is getting migrated here. So it is always advisable that you should sandwich your sample in between the silica. So after loading the sample, you can make sure that either you add the sand or you can add the silica slurry around 1 or 2 centimeter at the top of the sample cake, right? And then you can do the elution. Then you can run the column, then collect the fractions in the test tubes. So if you are doing for the first time or you are a beginner, then it is always advisable that you should use the number of test tubes with proper numbering, and then collect all those test tubes and then run series of TLC plates, then identify which test tube contains what fraction, and then you can collect those fractions which you should which you are interested actually, right? So that is what separation can be done, and then you should finally empty your column. So emptying column you can do by various ways. So what you can do to speed up the process, elute all the solvents using compressed air and allow air to flow through the column for approximately 2 hours. So what will happen? The solvent will be knocked out from the column. Then what remains? Only the silica and your impurities, and then you can easily invert the column and discard the silica slurry, silica, right? So you should be very careful while loading the column or handling the silica, because silica dust is very hazardous. You should not expose your body to the silica dust, because if you inhale that, it will create a problem, right? So it is not good for health. So usually people prefer to pack the column inside the fume hood, right? Once you pack, you can take out the column, and even when you are emptying the column, that also should be done in the fume hood, right? Then once you clean the column, then you can rinse that column with hexane, or after hexane you can add some acetone, so that the traces of impurities or whatever can be cleaned away, and then you can probably dry that column in the oven, keeping the tap in the upward direction. So that is how you can perform the column chromatography. So this is very important in synthetic as well as natural, and you can try if you are interested in taking and you will find there are little impurities maybe getting coming out even after the recrystallization, or the impurities which you cannot detect even on the TLC. So if you do the column chromatography, it will be always better, because if your compound is pure, then obviously the spectra which you are getting, that will be very neat and clean. When people do the synthesis, even we prefer to have the intermediates which we are getting formed. So those intermediates can also be column purified, and then you can subject it for the further steps. So that will give better yield when we compare the total yield of the product. So that's all from my end regarding the column chromatography. I hope you find it useful. This is what I have referred from the net. The reference is given. One video I have uploaded on my YouTube channel where I have shown the demonstration of how the blue and red ink is separated using a column chromatography. So for that the link is given here. And once again, thank you all of you for your patience listening. And if there are any doubts, you can text it. Thank you.
Those are having any doubts or any queries, please write on chat, YouTube chat.
Thank you so much, sir. Now, I would like to Professor Jyoti Sonone, ma'am, to give the vote of thanks also.
Good morning, all of you. I would like to thank our speaker, Dr. Amol Khade, sir. Thank you so much, sir, for your informative session on column chromatography and steps involved in column chromatography. It is very helpful session to all of us. Thank you so much, sir.
Thank you. Thank you.
Now, I am again requesting to Professor Manjusa Sanap, ma'am, to give the introduction about second resource person.
Thank you, Bharti. Now I introduce our second resource person, Dr. Vandana Jain, ma'am. Ma'am currently working as a professor in Oriental College of Pharmacy, Tanpada, Navi Mumbai. She completed her PhD in pharmacognosy from ICT in 2010 under the guidance of Professor K.S. Ladda, sir. Madam completed her MPharm in herbal drug technology in 2002 from MS University of Baroda, and she secured a gold medal during her MPharm. She is also a gold medalist in her degree. Madam completed her B.Pharm from B.R. Nahata College of Pharmacy, Mandsaur, Vikram University in 1999 with distinction. Her area of interest in analytical method development, standardization and stability testing of herbal drugs and formulation, extraction and isolation of phytoconstituent. Madam having a total 19 years of experience, 15 years of experience in academics and 4 years in research. She recognized as the MPharm and PhD guide from University of Mumbai. Vandana ma'am awarded by M.L. Khurana Award. She also received a Best Poster Award in 57th IPC held in December 2006 in Mumbai. Till now, Madam guided 25 MPharm students. Madam received a research grant from Mumbai University, from UGC New Delhi, and other universities. Madam published a book chapter, Overview and Recent Advances in Vitamins in Preventive and Therapeutic Role of Nutraceuticals Vitamins in CRC Press. Madam published 99 articles in different national and international journals. She organized different seminars and workshops in her institute. She attended around 26 seminars till now. She handled various instruments like DSC, UV spectroscopy, HPLC, LCMS, HPTLC, GC, as well as GCMS. Madam, we are very fortunate to have you with us in this 5-day FDP program and as a resource person. Many more to say about the madam. So the biodata is very, very long. So we just given a short introduction of Madam. Thank you, ma'am, as a resource person for our FDP. Thank you, ma'am. Now I request Madam to start their session.
Thanks a lot, Manjusha ma'am, for the nice introduction. Before I begin with, I would like to thank SS Jongle College of Pharmacy, Principal Dr. Nitin Moire sir, Manjusha ma'am, and all the organizing committee for giving me this opportunity. I'll share my PPT in a minute. Am I audible and is PPT visible? Just let me know.
Yes, ma'am.
Okay, thank you, ma'am.
Yes, ma'am.
Okay, thank you, sir. So my today's topic for presentation is HPLC analysis of herbal drugs, challenges and troubleshooting. As we all know, HPLC is a very good, sensitive, precise technique, but working with herbals poses so many challenges and we'll see how to troubleshoot them. So my presentation is basically divided into three parts. First, we'll see the quick review about the HPLC introduction, the different steps involved in herbal drug analysis by HPLC. So the presentation is divided into general introduction, followed by different steps involved in herbal drug analysis by HPLC. We'll see the challenges at each and every step and how to overcome those challenges. And at the end, we'll see few case studies wherein we have worked upon those herbal formulations or other polyherbal formulations. We have developed the HPLC method for those complex mixture. Why we need to do the HPLC? As we know, HPLC is a part of a standardization of herbal drug. Why standardization is required? The answer lies in the current market scenario. We can see there is a tremendous growth of herbal drugs right from 2015 and is expected to grow by leaps and bounds by 2026. In order to have the authenticity of the herbal drug in formulation or to have trust and patient compliance in these herbal formulations, one should standardize the formulation. And amongst that, the different steps which are involved in standardization of herbal drug, some basic technique, one has to begin with authentication. Then pesticide residue is one of the parameters that should be checked, microbial count, followed by microscopy, macroscopy, volatile matter, if it is present, ash value, indication of proper processing, extractive value, radioactive contamination, and then comes the most important, that is chromatographic studies of that drug. Chromatographic study can be performed by either HPLC or HPTLC or GC or any other chromatographic technique. And if it's a hyphenated technique, LCMS or GCMS, and nowadays HPTLC attached with MS is also available, then it definitely add on the advantage to the existing chromatographic method. Each method has its own advantages and disadvantages. Not going into the details about the other techniques, we'll see about how to develop the HPLC method for the herbal drug or polyherbal drug. HPLC, we all know, high performance or high pressure liquid chromatography. We say HPLC, but majority of the time we mean RP HPLC.
That is reverse phase high performance liquid chromatography, because the stationary phase being mostly non-polar, that is octadecyl silane. However, specific columns are also available which are used for specific purpose. The parts of HPLC system includes a solvent reservoir, a pump, it can be an isocratic or a gradient, a sample, which is a liquid sample, should be clear solution. We inject the sample through the column, that is our stationary phase. The components get separated based on their differential affinity, polarity, adsorption, partition and all. And at the end, the separated components passes through the detector, which is usually UV or PDA. Specific application includes refractive index detector, flame ionization, and etc. The elute passes through the detector and we get the response in terms of the chromatogram, wherein we have retention time on x-axis and response on y-axis. This is what the chromatogram we get, but this is not the actual picture we always get. Working with HPLC, the baseline, once it starts going up, it's difficult to get it down or bring it to the normal because herbals contain multi-component mixture in it. The different steps which are involved in HPLC method development includes, if someone is going to work or planning to work with a herbal drug, the first step is which formulation we should select, which herbal drug we should select. So first step for beginning with is the selection of the herbal drug or formulation. Once we have decided about the drug or formulation, what next? Which marker we should analyze? Unlike synthetic drug, wherein the API is 1 or 2, in herbal drug, we know that the activity is not because of one constituent, but it is because of a group of the constituents. Sometimes the entire constituent act for its bioactivity. So which marker to select? As the herbal drug contains many components in it. We'll see it in the coming slides. Which column to select? So again, based on the nature of the constituent, we can take a call about the selection of the column. Another important parameter to work with herbal drug is the selection of wavelength. While working with the simultaneous or multi-component drug, selection of wavelength is an with the previous steps, most important task is the mobile phase optimization, and then followed by the method validation as per the ICH guideline. Now we'll see this step one after another with some case studies at each and every step. So first is the selection of herbal drug and formulation. Which formulation to select or which herbal drug to select? Either it should be a novel drug, a drug which has not yet been worked out. Waiting about the drug, we are talking about the case where we have to perform the research, some new. The work we can do based on the reported method, but for the research purpose, we require something new. Some drugs which are well worked out, say for example, turmeric, ashwagandha, andrographolites, dalmed, clove, many drugs which are reported for their bioactivity are reported for their analysis as well. What new we can do? So we can think of some novel combination. There we have a researcher has an advantage that now in the market, many herbal formulations are coming up with different combinations of herbal drug. So there we can get a novel combination. So one should select a polyherbal formulation, a combination which is novel, or else if we are not working with a novel herbal drug or a novel formulation, we would like to work with an already reported method, reported constituent, then our method should be novel. How the method can be novel? If the method is reported for isocratic with an isocratic elution mode, one can develop an gradient method with advantages over the previous reported isocratic method. Or else, if gradient method is reported, one can give a try for developing an isocratic method, which itself is an advantages over the gradient elution method. So once we are selected the formulation, the next step comes the selection of the marker. We have an advantage over here that we have multiple things from which we have to pick one, two, or a number of based on the other parameters. So the marker, preferably everyone goes for the bioactive marker, the one which is responsible for the activity of the formulation. However, if bioactive marker is not available, one can go for the analytical markers as well for the standardization purpose. So now the formulation we have thought of, herbal drug we have thought of, markers we have to think either bioactive or analytical one. But again, there are certain other parameters which should be taken into consideration for selecting either the bioactive or the analytical marker. So what are those considerations? That includes first and foremost, concentration. We have a polyherb formulation containing n number of drugs, 4, 5, 6 or whatever it is. But which marker to select? If the marker which we are selecting is from the drug which is present in very less quantity, in that case we'll find a difficulty to get it detected in HPLC because there are other components which are present in larger quantity and hence we'll find it difficult. So concentration. So first criteria for selecting the herbal markers should be the drug which is present in more quantity in that formulation. Since it is present in more quantity in the formulation, it means it is the major bioactive component of that formulation. However, that is not always the case. So first consideration we should take for the concentration. Second comes, we have a formulation wherein one constituent is present in good quantity, the marker is bioactive, we know the marker is bioactive, but what about the availability? That is the practical challenge which we face. So we need to check for the availability of it. We should check with the suppliers how easily we can get it. Most practical aspect, if it is already available in the stores, in the college, with the research guide, with the student, then it becomes easy to select that marker, be it bioactive or be it an analytical one. Then comes the practical aspect. Cost is an important factor for the case where we don't have the grants. So these are some companies which offers the herbal markers, not advertising. I'm not advertising any specific brand, but Sigma Aldrich, highest purity, but it's quite costly. If one can afford, one should go for Sigma Aldrich. Natural Remedies from Bangalore also provide herbal markers. And Yuka Enterprises by Ladda sir also provides the marker at a quite reasonable and affordable cost. So these three parameters one should take into consideration while selecting the marker. Now we'll see one example wherein a polyherb formulation we have worked upon. So Leofeld tablet used for hepatoprotective property. Polyherb formulation containing multi-component. Just 1 minute. So which marker to select? We have Eclipta alba. Can someone tell me the marker for it? You can write in the chat box. So we can select the vidalolactone, an active marker, bioactive marker, vidalolactone. If we are going for phyllanthus, then phyllanthine we can select. Theoretically, if we talk about, we can take this marker. If we are taking this drug into consideration, that is rhubarb, we can select different anthraquinons. That includes aloimodine, then rhene, etc. So these are the marker from aloimodine, marker from rhubarb, one can select. Then Chicorium, then tinosporoside, then borevine, then Terminalia chibula, it's an tannin-containing drug, gallic acid, chabulic acid, etc. Calmake contains andrographolide, picrorhiza contains picrorizine, so we have an option to select different markers one, two, or multiple markers from this n number of drugs. But the consideration, as we have seen, first is the concentration of the drug present in it. Practically speaking, we need to check for the availability and cost of it. Some image from the Google I have taken, vidalolactone. The cost of it goes 1 milligram of andrografolide cost 4,400 rupees. However, we know 1 milligram is very less. To work with an HPLC, minimum of 10 milligram we require, and that costs 10,000 rupees. So if one can afford and has the grant to purchase this much, one should go for an active bioactive marker, that is vidalolactone. But considering the other parameters, we should take a call. Another example from Phyllanthus is phyllanthene, present in Phyllanthus neruri. See the cost of it. It's 1 milligram is costing hundreds US dollar. Until unless you have a big, huge government grant, it's difficult to purchase this. 5 milligram is costing 250 US dollars. So there comes the practical aspect. Theoretical aspect says we should go for the biomarker. Theoretical aspect says the drug which is present in more quantity, we should select that marker. But practical aspect says what is available with us or else what we can purchase. So this too goes for the costlier marker. So we have other markers, other components present in the polyhaba formulation, that is Calmec containing andrografolide. 100 milligram is costing 6,000 rupees, still affordable. And again, the price, as I said, price ranges between from Sigma Eldridge to Yucca Enterprises. However, there is a difference in the minor purity of the drug, and one can take a call between the cost and the purity. So 100 milligram of andrografolide is still affordable. Another marker, if we have to select, if it is not still affordable, then comes the gallic acid. Gallic acid is, we know, is present in n number of drugs, especially tannin containing drug. 98% pure gallic acid is available, 100 gram is available for 1200 rupees. So there comes the practical aspect. One can select at least gallic acid as one of the marker and other markers for simultaneous estimation. Since gallic acid is already reported, method development for gallic acid, you will find n number of HPLC methods for gallic acid. But then, if one method is reported, that does not mean that you can't report a second method or third method or other method. Only thing is that our method should have the advantages over the previously reported method. And combining with other markers will make the method novel. So we have selected the marker. Now comes the selection of column. We usually works with C18 column, that is octadecyl silane column, particle size, dimension, and stationary phase being the C18 one. However, apart from C18, there are different other columns which one can use. That includes, just 1 minute, are my slides changing properly? Can anyone help me out? Okay. Manjusha ma'am?
Yes, ma'am, it's proper.
Okay, thank you ma'am. So, different columns are available. We usually use C18 column, but we have the option to use some other columns as well. Say for example, this is, I have performed caffeine HPLC on different types of column. This one is C18, this one is C8, and then this is with larger particle size. This is Sino column. This is HICIL column. So different columns, one can perform the analysis, but we go with C18 because the separation and the retention is quite good in C18. However, C8 can also serve the purpose. We know cyano-amino column are for very specific purpose, doesn't work for our compound of interest. Then comes selection of column. One should use guard column also. Guard columns are relatively cheaper column, and they protect our expensive analytical column. As we know, herbals are the mixture of multi-component drug, so the column gets spoiled very easily, the active sites get saturated very easily. So in order to prolong the shelf life of analytical column, one can use the guard column, which acts as a chemical trap and prolong the shelf life of the analytical column. So column we have selected, which usually we C18, but however one can work with C8 as well for our general compounds. Then comes the selection of wavelength. As a general rule, if it's a single component, we are analyzing one marker only from a synthetic or herbal drug, we go by the UV maxima of it. Quite simple, but it is not simple as it looks like if we are working with a multi-component drug. So if we have 2-3 markers, then we should go for the isobestic point, a point wherein all the components shows appreciable absorption. Again, theoretically speaking, it's fine, UV maxima, fine, isobestic point for multi-component, it's okay. But then comes the practical aspect, that is concentration of the marker in our formulation. So that should be taken care while selecting the lambda max. We'll see with some examples. This is the UV overlength spectra of quercetin and flavonoid, a flavonoid, and an ellagic acid, a polyphenolic constituent. So the picture is simple here. We can go for the common UV maxima that comes around 260 or so. So one can take this as a wavelength or one can take this as a wavelength. However, here the ellagic acid is showing more absorption. Quercetin is showing same absorption at both this maxima. So one can select 250 or 255 more precisely as a lambda max. The case is simple here. Now let us see another example wherein we have added the third component, that is piperine. Now in this, my student, MPharm student, have performed the HPLC analysis of 3 components, simultaneous estimation of ellagic acid, piperine and quercetin. Now which wavelength to select? Then comes into the picture the concentration. If we go by UV maxima, ellagic acid and quercetin shares common UV maxima, and piperine has a UV maxima at around 245 nanometer. Isobestic point, if we think about, then it goes somewhere here. But then comes the third point into the picture, concentration of that marker in our formulation. So, if in our formulation piperine is present, the pepper containing piperine is present in very less quantity, but we have selected it as one of the marker because it was available with us and it is quite reasonable, we can afford it. So in that case, piperine is our critical factor, present in very less quantity. So we can go for this wavelength for HPLC method development. And think of another case wherein piperine is present in more quantity, but the drugs Terminalia, Chebula or Amla or Herdapaheda, all tannin-containing drugs, which are present in less quantity, but we have selected ellagic acid as one of the marker. In that case, one should go for 250 or 55 nanometer as a wavelength for analysis because this is our critical component which is present in less quantity. So we should take this maxima for our method development. Another example wherein we have performed HP simultaneous estimation of ellagic acid, rutin and quercetin. Rutin is the glycoside for quercetin, so has the similar maxima, only difference is in the presence of the sugar. So here the case is simple, one can go for 250 plus or one can go for 360, around 360 nanometer. So this is how one should select the UV maxima. First is the based on the UV maxima if it's single component analysis, or isobestic point if it's a multi-component analysis. But practically speaking, one should take into consideration the concentration of API or marker present in our formulation. Another case, all components are absorbing at different wavelengths. So which wavelength to select? So herein we have performed the simultaneous estimation of piperine, camphor and curcumin. So again, theoretically speaking, this is the wavelength 210 or 220 is the point wherein all the components are showing appreciable absorption, but there is a twist again here. Working with herbal drugs, if we take the wavelength near to 200 or 220, there is a lot of noise and disturbance. And as we move towards the 400, the spectra, the chromatogram becomes more clean. So if we have to select amongst the wavelength near 200 or far 200, the choice should always be the wavelength which is far from 200 and not near 200. In that case, we'll get the minimum disturbance and we'll get the clean chromatogram. And again, concentration one should take into the consideration. So herein, if camphor is present in lesser quantity, where camphor is our critical factor, then we should select this 200 around 72 for camphor. If piperine is present in less quantity, then we should say go for 345. And if curcumin is present in the less quantity, then one can go for 260. Curcumin also shows maxima at 425 being a colored compound, yellow colored compound, but we cannot select 425 because other these two are colorless compound and then they don't show any absorption at 425. So selection of wavelength should be based on the concentration of the marker in our formulation. Next important step is the sample preparation. Working herbal, polyherbal, again there is a difficulty. The available solvents, the different steps involved in the sample preparation is first, we should select the solvent, in which solvent we have to prepare our sample, and second, by which method we should extract our sample. Selection of solvent, we usually works with 3 solvents working with RP HPLC, and that includes first one is methanol. Methanol is most widely used because it can dissolve maximum of our organic component as well as it dissolves the tannins, flavonoids and glycosides as well. Another choice of solvent for extraction is acetonitrile. One can give a try extracting this drug in acetonitrile as well with an added advantage if our selected marker are soluble in ACN, then ACN being more specific, one can avoid the unnecessary disturbance or interference from other compounds. So one can give a try extracting the drug with ACN as well. And sometimes we have to go with hydroalcohol if our compound of interest are soluble requires water in the sample. So one can take 50-50 hydroalcohol or 70-30 or 90-10 likewise. However, using water makes the sample too crowded or too many components, sugars and all unnecessary required component will also come into it. So we can say that hydroalcohol is a less specific solvent, so should be avoided. So we have selected the solvent. Now let us see by which method one should extract the sample. We usually have these options available with us. One can do the reflux of the sample with the selected solvent, or else one can use the Soxhlet extraction technique using the selected solvent, or else one can give a try with sonication also. All these methods have their own advantages and disadvantages, and these includes if someone is going with reflux is very fast technique. Refluxing the sample for 20 minutes solubilizes all the required components. It is effective because we are adding the heat for facilitating dissolving the components, but then this reflux method is not suitable for thermolabile component, for glycosides, for the compounds which degrades upon exposure to the heat. Another technique one can use is Soxhlet. Soxhlet is also effective in extracting out the active constituent. Only thing is that compared to reflux, Soxhlet is a time-consuming activity. In reflux, one can get the sample ready within 15-20 minutes. For Soxhlet, you need to at least run it for 4 hours to get the maximum complete extraction. One good technique is by sonication. Sonication is more preferable for thermolabile. It is only effective when we subject the sample to sonication for a prolonged period. So we can say it's a time consuming. However, if thermolabile constituents are there, one can go with the sonication of the sample. So our sample is ready by selecting the solvent and by subjecting it to either reflux, oxalate or sonication. It goes without saying, whatever sample we have prepared, it should be clear. One should filter it and then a clear solution should be injected. And one more thing one should take into consideration is the concentration. We'll see in the coming slide as well. Always start with a less concentrated solution, because injecting a higher concentrated solution to into the HPLC in the starting will lead to the tailing and decrease in the column efficiency. So one should begin first with the dilute solution. Now coming on to the most important and tricky task, that is mobile phase optimization. Separating one component amongst hundreds of constituents is really a challenging task. So we have to do trial and error by using different combination of solvents. The approach for mobile phase optimization should be, firstly, based on the literature. If the compound is reported, the HPLC of the compound is reported, one can take the lead from the literature. Good journal paper should be referred rather than non-index journal. And secondly, if we are developing a novel method, it's by trial and error. Now here, the tip is that if you are working with a multi-component drug and the combination is new, however, if we say, for example, we have seen the previous example wherein we have worked with camphor, piperine and say ellagic acid. So all these three components are, HPLC of these three components is reported, but separately. Combination is not reported. So based on the literature, we should review the reported method for all these three compounds. And let us take a call where we can combine that method. Or else, if there is a common method for two of the component, use that method and try to add on the third component into the method, and by trial and error, develop the method wherein we can resolve all three components. Selection of solvent for the mobile phase optimization. Working with an isocratic elution, we have the choices. The available choices includes a methanol, using methanol as an organic phase and water as an aqueous phase. So if we have to begin from the starting by trial and error, if reported literature is not available, in that case the trial and error should begin with methanol and water and varying the proportion. One can begin directly with 50-50 and later on varying, increasing the organic phase or increasing the aqueous phase based on the polarity of the component or markers selected. However, this methanol water usually doesn't work out. We require an acidic component or buffer into it for proper resolution of the peak. So one can give a try by using methanol and buffer. We use KH2PO4 buffer, sodium phosphate buffer. So one can try a combination of methanol and buffer, and the trial includes by varying the proportion of methanol with the buffer prepared by varying different combination. Begin with 50-50, try with 70-30, try with 30-70. And a choice should be taken based on the polarity of the component present into the sample mixture. One trial should be based on varying the proportion. In case if it doesn't work out, one can give a try by varying the pH or concentration molarity of the buffer as well. That also works well for proper resolution of the peak. If methanol is not working out for our component, it happens sometime. So then the choice of solvent comes to the acetonitrile. Acetonitrile gives sometimes better separation over methanol. So one can give a try using ACN and water in varying proportion. Usually one can begin with 50-50 and then switching to 70-30 or 30-70. That will give us an idea whether more organic component is required or more aqueous component is required for proper resolution of our peak. Now working with herbal, there is one more thing which one should take into consideration, when we work with herbal HPLC analysis, we should try for getting uh, the larger retention time. If the compound will elute at 2, 3 or 4 or 5 minutes, the compound will not be resolved properly. So if we want proper resolution of our marker, then the marker should be eluted at least after 4 to 5 minutes so that it will be resolved from all other undesired components. We'll see the chromatograms in the coming slides. Then if this works out, which usually doesn't work out, we need to have the buffer component, we need to change the pH of the mobile phase, and there one can start the trial with ACN and potassium dihydrogen phosphate buffer by varying the proportion of ACN and buffer or by varying the pH of the buffer. Now, if we are working with multi-component, we have 2 components or 3 components, and with this trial, we have come to know that one of the peak is eluting better with methanol and buffer, and another component's peak shape is more proper with ACN and buffer. What next? So we can go with the trinary mixture in that specific case, wherein one component is requiring methanol as an ingredient, while other component is requiring acetonitrile as in mobile phase. There, one can give a trial for trinary mixture. So based on the above 2 observation, one can think of taking methanol, ACN and buffer. Therein we can get the proper resolution for our multi-components which we have selected for analysis. But remember, whatever trial we do, one should vary one parameter at one time. If we are varying the proportion of buffer and organic phase, we should vary that only. At one point, vary one parameter only. And if we want to vary the pH, first set the proportion, then change the pH. Because if we vary 2 parameters at one time, we will not get to know because of which parameter our peak is getting resolved or distorted. Working with gradient elution, which require a sophisticated system, high-end HPLC version with quaternary gradient pump. So gradient elution is preferred for a mixture which is complex in nature and which contains the marker ranging from the polar to the non-polar. So if we have selected the markers of which one is quite polar in nature and we have selected another marker which is too non-polar in nature, in that case, a isocratic method of elution will not help in resolving this 2 component in one run, and therein we need to go for the gradient elution. We'll see this example in ascorbic acid, which is water soluble, and we have developed the simultaneous.
Ma'am, Vandana ma'am, PPT are not visible.
Polar. Then comes the method validation. So method should be developed by trial and error using different combinations of acetonitrile, methanol and water, or we say buffer. Now method validation one should do as per the ICH guideline that includes specificity, precision, interday, intraday, then accuracy, then robustness and all these parameters. I have selected some parameters which requires our serious attention, and that includes resolution, a very challenging task to get the peak resolved in a herbal drug. How to begin with? We have our sample ready, we have prepared the sample, our marker, we have prepared the solution, our method is ready. Now, which concentration we should begin with? Unlike a synthetic drug wherein the label claim is mentioned, say paracetamol tablet is there, it is written 50 milligram. So we know the sample, how much sample contain. Accordingly, we can prepare the solution and we can select the marker. We can select the standard concentration, but that is not the case with herbal drug. So we'll see how to set up the range for linearity and other working parameters. And also which sample concentration to be injected, whether we should prepare a solution 1 gram in 100 ml or we should prepare 100 milligram in 100 ml, that requires our attention. And there's one parameter which is of very practical importance to us, that is solution stability of the markers. We have seen that the herbal markers are quite costly. So we sometimes we have to work with a smaller quantity only. So we should check the solution stability so that, yes.
Vandana ma'am, sorry to
Yeah.
disturb you, but PPT are not visible.
Oh, okay, ma'am. Just 1 minute. Give me 1 minute. I'll work it on that.
Yes, yes, ma'am. Now it is visible, ma'am.
Is it on screen, ma'am? I'm sorry for the disturbance. I don't know how come this has happened, but it's okay. We'll begin with. So we have seen that isocratic illusion. One can take a call between methanol, ACN, or a trinary mixture containing methanol, ACN, and buffer. Only thing is that vary one parameter at one time. If one is working with gradient illusion, which is usually required for complex mixture and based on the polarity of the marker, we select the method. If we are working with a mixture of non-polar and a polar marker, there we require a gradient illusion. Say, for example, as I said, ascorbic acid, which is a highly polar one, and a thymol, which is soluble in actually chloroform. So if we have to develop a simultaneous method of ascorbic acid and thymol, there the isocratic method will not work, and gradient illusion will be of help to us by varying the mobile phase composition over the period of time. We can resolve the polar as well as non-polar component in one chromatogram. Now coming on to the method validation parameter. As per the ICH guidelines, different parameters are there that includes specificity, precision, interday, intraday, linearity, range, accuracy, and robustness. I have specifically taken some parameters which requires specific attention. That includes resolution. As we have seen that resolving a component amongst the hundreds of components is a challenging task. So there comes mobile phase optimization into the picture, which should be well resolved. Then comes setting up the range and sample concentration. Unlike synthetic drug, wherein we don't know how much quantity of marker is present in the herbal drug, there is no label claim. Even if label claim is there, it's simply mentioned turmeric 20 milligram. Sometimes it is not even mentioned, it is turmeric powder or turmeric extract. So we need to decide the range for linearity or standard, and we need to decide the sample concentration which should be injected. And another important parameter which should be checked is the solution stability. As we have seen, the markers are quite costly and we need to work with a small quantity of markers. So solution stability should be checked for the herbal markers. Resolution. This is one method we have developed for simultaneous estimation of gallic acid, abbreviations we have used, wherein we have developed the method using isocratic elution for gallic acid, protocatagic acid, then vanillic acid, and then syringic acid. Looking at the chromatogram, what does it say? The peaks are resolved? Yes, they are. They are quite well resolved. But now then comes the twist. Here we have used the mobile phase as a simple isocratic elution wherein we have used the methanol and 0.1% of acetic acid in a proportion of 25 to 75. We have tried developing the method with the markers and we found the method is quite good and all the markers are well resolved within the duration, within a 10-minute time. Now let us see the sample solution for the same method. This was the picture when we run the sample mixture into the developed method. So our task is not over yet. Here you can see the peaks are not resolved. This is gallic acid, then here is protocatagic acid, then vanillic acid and syringic acid. Comparing the retention time, but the peaks are not resolved. As I said earlier also, working with herbal drug, our task, our plan should be to retain the compound for at least 5 minutes. So before 5 minutes, all the unwanted impurities or undesired component will elute out and our component will be resolved properly. So in this case, we have seen, although the markers were resolved, but in the sample, the resolution was poor. So again, we have to do the mobile phase optimization. We had to play with methanol, water and ACN and we have done different trial and errors. And herein, we have changed from methanol with methanol and from rather than acetic acid, we have tried developing the method using orthophosphoric acid and the ratio also we have done minor change, that is 20% organic phase, 80% aqueous phase, and this is what the picture we got. The runtime was increased, but the resolution was too good. And then this was the standard mixture solution wherein 4 peaks were separated and this was the sample mixture. Here you can see that all the peaks were well resolved. This is gallic acid, then protocatagic acid, then vanillic acid and then syringic acid. So resolution, resolving the peak in herbal drug mixture is a challenging task. Our plan, our target should be to delay the retention time a bit or more based on how many components you have selected so that you get a well-resolved peak. Next parameter is setting up the linearity range, which concentration we should work with. For linearity range, shall we go from 1 to 10 microgram or we go from 10 to 100 or 50 to 100? That should be checked. How to check this? And what should be the sample concentration? I have taken an example wherein we can begin with as a rule or as a trial and error, one can begin with 20 ppm because it is usually a reasonable concentration, not too high and not too low. So one can prepare a 20 ppm of the standard or marker solution in the suitable solvent in which it is soluble, which is usually methanol or ACN or the mobile phase. So prepare a 20 microgram per ml solution of the marker, inject it at the selected wavelength. In the next step, prepare a sample solution. Again, for example, I have taken, since we have to set up the range for linearity and we have to set up the range for sample concentration, so we have to prepare 1 gram of sample, extract in 100 ml using either reflux or sonication or Soxhlet assembly. So now we have this solution of marker, we have this solution of sample. We'll inject both the solutions separately in the method developed by us and we'll get a chromatogram wherein we'll get at a certain specific retention time, we'll get certain area under the curve. So we'll get the area under the curve for the marker, for the selected marker in the sample and in the standard chromatogram. Now, based on that area, we have to back calculate and set up the linearity range. An arbitrary example and area I have taken that can help you, that can help us in setting up the linearity range and sample concentration. For example, we have, as we have seen, we have prepared 20 ppm of solution, and we got, for example, it's an arbitrary example I have taken. So we have got 20,000 area under the curve for that marker which we have injected. We have prepared the sample of 1000 ppm. We have prepared a sample solution of 1000 ppm, and we got the area of 5000 area under the curve. Now we have to back calculate what should be our sample range or what should be our linearity range. Now there are two things here, and there are two things which one can go with. Either decrease the standard concentration so that the sample concentration fits into the linearity range, or else increase the sample concentration so that sample concentration fits into the linearity range. Which one to go for? Usually with working with the herbals, one should go with the dilute concentrations only. Injecting higher concentration will give the tailing to the peak and decreases the column efficiency. So if this is the case wherein we are getting 20,000 area is corresponding to 20 ppm. So 5,000 area corresponds to how much ppm that we can calculate. So here 20,000 ppm and 5,000 ppm, there is a difference of four time difference is there. So either we should increase the sample concentration 4 times, or we should decrease the standard concentration 4 times. Decreasing standard concentration is always beneficial provided the method meets the system suitability parameter. The theoretical plate should be greater than 2000. So if we see this case, so if we keep the sample concentration as the same with what we have prepared, we can decrease the standard concentration and keep 5 ppm as our middle point for linearity, or we can say working concentration or 100% concentration middle point. So we can set the linearity range from 1 ppm to 10 ppm. So when we inject this sample of ours, the sample concentration, the sample area will fit into the linearity range. So this is how one should set the linearity range and sample concentration. One important parameter one can go with that will be of great help in working with the herbal markers, as they are quite costly. Check for the solution stability. That can be done during the precision studies, interday and intraday. So prepare a stock solution, say 20 ppm solution, that is our working concentration or middle point of the linearity, and inject that solution over the period of 24 hours, 48 hours or 72 hours. So that will give us an idea whether this API, the marker, is stable in the solution for how much time. If it is stable for 3 days, then we can use the same stock solution for preparing the different dilutions over the period of 3 days, or even if it is stable for more days, one can check with. So this performing solution stability is of great use to reuse the solution over the period of analysis. This is most helpful for working with the costlier API. And during my PhD at ICT, I have worked with vidalolactone, then gugasterone, then gingerol, and all this cost that time 10 milligram for 10,000. Now these markers cost 10 milligram for 25,000. So one cannot afford grams of API. So there we first check for the solution stability, and we keep the solution in fridge. And we took out before analysis half an hour or so. We checked the solution stability, whether the area is same or not, and use the same solution over the period of a month or so, provided the marker is stable. So this is about the different steps involved in the HPLC analysis and how to resolve the challenges posed during each and every step. 2 case studies I have included. This is one method wherein we have done the simultaneous estimation of andrographolide and berberine in polyherb formulation. It was a novel method reported by us. This combination was novel. So this we have seen in the different steps, that which formulation to select, which marker to select. Andrographolide separately is reported, berberine separately is reported, but the HPLC combination of this 2 drugs is not reported. So we have developed this method and published in a Scopus Index journal. So again, I have taken this repetitive slide just to see, we'll see all these steps with respect to this combination. So this was our formulation, which we have taken up, a polyherb formulation containing Tinospora, Andrographis, Eclecta, Phyllanthus, Ocimum, Borrelia, and XYZ multi-component. Now, we have selected the marker based on the concentration, based on the availability and based on the cost. So we have selected like tinospora. We know tinospora contains tinosporoside, but tinosporoside is very costly and was not available with us. What to do? What to do? But then the literature says that tinospora also contain berberine as an berberine alkaloid in it. And berberine was available with us, and berberine is not that costly. So we have selected berberine. Berberine is also an important active bioactive component. So we can say we have taken bioactive marker. Andrography contains andrographolite, which is reasonably available. So we have selected these two markers. However, if someone has vidalolactone available, one can try developing the method for this three combination. Phylantine, if one can afford 1 milligram for $100, one can go for this as well. And there are other markers one can take up on. But this case study I have taken in which we have selected two markers, andrographolite and berberine. This is the UV spectrum we have taken. The case was simple, wherein both compounds were showing appreciable absorption at 225 nanometer or so. So we have selected this wavelength for our further HPLC analysis. Now, mobile phase optimization. So we have taken the lead from the literature. We have started with the reported method for andrographolite or berberine separately, and we tried to combine the other marker in the previously reported method. But when we tried the previously reported method, we found that there was a tailing in the peak. The peaks were resolved, but there was tailing in the peak. Is this PPT visible or it is again gone out of sight? Manjusha ma'am, is this PPT visible?
Yes, ma'am. This is
Okay. I thought there is some technical issue, so just confirm that. So the pH was 2.3 and we modified a bit. So we get to know that we are nearby wherein peaks are resolved. But there is slight tailing, so slightly change in the pH of the mobile phase gave us a proper resolved peak with good symmetry. So herein we have changed the pH from 2.3 to 2.2 and we got a proper peak keeping the mobile phase as SCN and KH2PO4. And we have checked all other parameters. So this is the specificity, blank chromatogram showing no peak at the retention time of the markers. This is the chromatogram of a standard mixture, well-resolved peak with proper symmetry, meeting all system suitability parameters. And this is the sample chromatogram wherein both the peaks were well-resolved. Again repeating, working with herbal solution, we should try for getting the peak after 5 minutes so that we can get rid or we can avoid the interference from all unwanted components, undesired components. Another case study, second and last case study, is the simultaneous estimation of 5 components in a polyhabo formulation. This we have done, if you look at the markers selected, the ranges from the highly polar one to the non-polar one. Ascorbic acid is highly water soluble. Thymol is freely soluble in chloroform, slightly soluble in methanol. So we have developed the method for ascorbic acid, gallic acid, ferulic acid, piperine and thymol. They are the compounds in the increasing order of their polarity. So this development is difficult in an isocratic elution. We require a gradient elution with changing the mobile phase composition over the period of time. This is the formulation which we have taken up. We have selected the marker based on the concentration, based on the availability and based on the cost. So fortunately, we could afford ascorbic acid. All the markers were affordable and are present in good quantity. So terminalia acid, we have taken gallic acid. Ferula poetate acid, ferulic acid. Pepper contains piperine and ajwain contains thymol. Carbon would have been added, but it was not available. So we skipped that and we developed the method for the 5 components. These are the inorganic excipients added into the formulation. Here is the UV overlay spectra of this 5 components. Selecting the wavelength is again a tricky task. So this is the overlay spectra. If you look at the spectra, this is the point wherein 3 of the components do not show any absorption. And as we know, beyond 220, we should keep the wavelength for herbal drug because there is a lot of interference if we keep the wavelength towards 220. So we had an option of selecting the wavelength from 220 to say 280 or 90. And then we have taken up the 272, we have done the trial with 2-3 wavelengths, we have injected the sample and we have injected the API, and we found that at 272 nanometer, all the compounds were showing appreciable absorption. We have developed the gradient method for it after several trials and error, which I have not added here. So after several trials and error, we have found that since the component contains the polar component, that is ascorbic acid, and the marker selected is thymol, which is quite non-polar in nature. So we need to have good quantity of aqueous component in it, and we need to have good quantity of organic component as well in it for eluting both these components. So we have selected aqueous phase as a 0.1% acetic acid and organic phase as an acetonitrile, and we have run the method starting from initial A. A is our aqueous phase, 90% aqueous we have kept initially, and we have gradually decreased the aqueous component. We have brought it to 10% of aqueous, and we have increased the organic phase, that is acetonitrile, from 10 to 90%. And this is after 5 minutes, we have set to the original condition. We have kept it for equilibrium for 1 minute, so system is ready for next run. So with this method, we have observed all the 5 peaks were uh, properly resolved with good resolution, asymmetric factor, and all system suitability parameters. This is the chromatogram of mixed solution, wherein you can see the ascorbic acid followed by gallic acid, ferulic acid, then piperine, and then thymol. So these compounds have eluted in the increasing order of their polarity. Ascorbic acid being maximum polar, thymol being maximum non-polar. So this was the mixed standard solution. We have run the sample chromatogram. And we have found that all the peaks were well resolved and the method was set. Again, we have struggled. What is this peak for? We initially thought it is some degradant or some impurity of the API, but then when we run the blind chromatogram, we found that the gradient transition is showing a deflection at this point. So the method is specific because this peak belongs to the blank transition and is not interfering with the peaks of the last where we know one should go for HPLC herbal analysis or not. There are certain advantages for using accurate, robust, reproducible, and all HPLC advantages are applicable to herbal drug as well. However, the difficulty is with respect to the complexity of the component, and HPLC as such is costly as it requires frequent changing of the column, especially with the herbals. So this is with this I conclude my presentation. I would like to thank Jonle College of Pharmacy for giving me this opportunity. I would like to thank Pavan Chopre sir from Oriental College of Pharmacy for facilitating the matter. A special thanks to Vijay Ikale sir, a faculty at OCP, who has helped me in beautification with animations in this PPT. And thank you all, wonderful audience, for today's presentation. Thank you, everyone. Question answer, if you have any, please let me know.
Those are having any questions, they write on Google Live. Those are having any questions, they write on Google Live. Sorry, YouTube Live. Yes, Manjusha ma'am. Yes.
No question from participants.
Okay, ma'am. Thank you.
Go towards the vote of thanks. So I request Jyoti Sonone ma'am to give a vote of thanks.
A very good afternoon to all of you. I would like to thank our today's speaker, Dr. Vandana Jain ma'am. Thank you so much ma'am for your informative session on herbal drug formulation on HPLC, in which different techniques of column chromatography like HPLC, HPTLC, GC, etc. Selection of wavelength, mobile phase optimization, method validation, parameter like resolution, setting up the linearity range, solution stability. You very well explain the case study example of simultaneous estimation of andrographolide and berberine in polyherbal formulation and also other example. It is very helpful session to all of us. Thank you so much, ma'am. I would like to thank our beloved principal, Dr. Nitin Moire sir. Thank you so much, sir, for arranging this FDP, which is very knowledgeable, helpful for future. I would like to thank our coordinator, Professor Manjusa Sanok ma'am and Mr. Ganeshmal Chaudhary sir, and also thankful to our coordinator and supportive staff. Moving to the next, last but not a least, our below audience. Thank you for joining this session. Thanks to one and all for your valuable time. Have a good day. Thank you. Thank you, all of you.
All the participants, the feedback link is given on YouTube chat. So fill the feedback link. All the participants to fill the feedback link which is given in YouTube chat. And also request to all the participants to timely join tomorrow's session. Fill the feedback link. Thank you, and Dr. Vandana Jain ma'am. Thank you very much.
Thank you, ma'am. Thank you, everyone.